Okay. What is indexing? What is indexing? Why do we need it? So far, we've been talking about queries, right? Thinking and always working on a very small data set, no? The max we went for was, I don't know, 20, 50, right? But in a real world, if you're working for IBM, Amazon, Facebook, whatever, wherever you end up going, they have millions of records, yeah? Then you don't just write a query and say, this will give me the answer and that's it. You need to find out if that query is fast enough, is quick enough, okay? So if I come to your website, let's say you have an e-commerce website, you own a company. If I come to the website and I search for a product, I don't have to go grab my copy and come back to see the list. It has to be quick, no? Otherwise, I go to another website. There are plenty of other websites that are faster than yours. So what is indexing? Is a process that makes a search faster. Okay? We're cool about that? All right. Is it only about select a statement? What gets faster by indexing? Is it only the select a statement? Because we have search in the select a statement, no? That's it? Update, because we might have search in update. Delete, we might have a search in delete, right? What about insert? Does it make it faster? It doesn't change the speed? Or does it make it slower? It doesn't change you. It doesn't change. It doesn't change. It doesn't change. You sure? We'll explain why that is a wrong answer, okay? But now let's just have a look here. My query is as simple as this, and I want, again, I'm trying to simulate something that is very abstract, okay? I have not been inside the server to see if this is exactly how it works, okay? So this is just for you to be able to visualize it. All right, let's have a select a statement. Select a star from, let's call this country A, okay? From country A. What is going to happen when I run that query? It's gonna go to each column, each row, and print the data for you, right? It comes here, right here. What is this guy? That's new, no? I'm gonna make it like that, and we'll come back to it. Okay. Then what happens if I replace this with, let's say, fname? I select the column, or the server selects the column, then goes to the each row, prints the value for that selected column. Correct? Not difficult to understand that, no? Now what happens when I do where age greater than 26 or equal? Now what happens? I choose the column, right? Then I go to each row and ask a question. Is this greater than 26? No, 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 yes, yes. So I print this and I print that. Now imagine if you have 10 million rows. I have to visit all the 10 million rows and go to that value and check the condition. Do you think that is the ideal way to do it? No. Are there better ways to do it? How do we improve it? Using the indexing. We have two types of indexes. We have 5 types of indexes, but we're going to cover 2 in the lab, okay? We're going to cover the B tree and the hash, okay? So how does and it's the B tree doesn't stand for a binary tree. It's a balanced tree, okay? So the quiz might say B tree stands for a binary tree. Be careful because it doesn't, all right? So this is the root. How do I work this out? if I ask you this question, give me all the age about 26, yeah? What is the first thing that comes to your mind that's going to help you speed this up? Ordered, right? Very good. You're very sharp today. Good. All right. So first thing I need to do is get this ordered, right? So it would be, for example, 18, 20. Was that ordered already? No, roughly. Not exactly, yeah? So let's do this. And then replace this one with this one. And I'm going to copy this guy here, okay? And I think this should go here, and this should go here. Okay. What's going to happen next? When you do an indexing, a B-tree indexing, it creates a balanced tree. How it balances is up to the server to do it, okay? The balance means I should spend the same time going to the left side and the same time going to the right side, roughly, not exactly, okay? So what happens? Let's say it happens like this. It comes here and says anything between 15 and 25 should come here. So we don't need that, basically. We're going to keep it simple, okay? And then anything between 26 to 40 should come here, okay? Then it goes and says, okay, here I'm going to have, what do I have here? I have 18, I have 20, and I have 25. Okay, let's put that one like that. And here I have 32, not 35, okay? And I have 35. Imagine the links between them, okay? I don't have time to create the links right now. Okay, those are intermittent link. They are actually linked together. So I'm gonna insert this one right there. So all these nodes are linked together, okay? So they can go back and forth, okay? So I'm not gonna repeat this for all of it, but you can imagine what I mean, right? Let's repeat it because I don't trust the imaginations anymore. And let's create that link from here. Shape, get me that. This comes here. Another one comes here. Another one comes here. Another one comes here. Again, it's not exactly how it looks, okay? It's just for you to see how it looks, roughly. Okay? Something like that. Okay. Now I ask you a question. These are the internal nodes that are telling us to go left or right. Remember, the left is smaller than the right ones, right? And these are the last leaf nodes that are telling us about the data, right? Do I return it once I find it? Like I come here, I go like, should I go left or right? You tell me, guys, should I go left or right? Right. So I come here. So imagine how many I ignored. This whole thing I don't have to check anymore. Then I come here. 26 to 40. Okay. Is this between 26 to 40? Yes. So I'm going to highlight that. Then I go to the next one. Is this between 26 and 40? Yes, I'm going to highlight that. Do I return it directly from the index structure? The answer is no. Okay, both B-tree and hash are called secondary index, which means what you get here is a row ID. You always have to go back to the actual table, which is called a heap table. So how do I do that? Is these guys have the row ID with them. So 32 would be BG70. Why it happened like that? Something like that. And then here, this was 35. This one would be BB81. So what happens now, I know that it's in here, right? BG7, I come here and say BG7T, return this. And then I go to this one, it's BB81, return this. Okay? We get an idea of how B3 works? Okay. Is this fast? Yes. What is it best for? You can see there is a range, no? Go left, go right. It's always a range of data, no? So it is both for range, no? What about equality? But there is a problem with it, no? It doesn't directly get me where I want. I always have to go left, right, left, right, left, right to get where I want, okay? Now, imagine there is, okay, first let's do the B3, okay? So you get this. This is the value I'm looking for, the marker, okay? And I'm here, and you are my B3. Where do I go? Where do I go? Well, there is no straight, but okay, let's say left, right? I still go left, no? Then I get this. It was fast. I didn't need to go to each one of you and look for it, right? It's faster than that. Now, imagine there is a robot here. Yeah, I'll give it back to her. And I ask, I'm looking for a marker. Which way to go? It's like, that's the ID where it has your marker. It's a straight away. So I go here. I get my marker. How fast was that? Much faster, yeah? What was that? The function is the hash function, is this one, that takes each value, converts it into an ID, okay? So this becomes, for example, 1, 2, 3. This guy is also 1, 2, 3, no? Right? It's the same thing. I made them the same thing, okay? Then this guy becomes maybe 1, 2, 4, 1, 3, 4. This guy is the same thing, so it comes here. What are this? These are buckets, okay? For example, it says this bucket, that bucket, or that bucket, okay? So it doesn't tell me left and right. The hash function would tell me go to the bucket 2 and go straight away, okay? So what happens here is all these are getting converted to, it's much easier to work on a board than to work. So this is coming here. From here, it's going there, okay? So when I search for this guy, I don't go left, right, left, right, left, right. I go to the hash function and tell it, what's the ID for this guy? It tells me the ID is 1, 2, 3, and it's in bucket number 1. What do I need now? Does it return me the value directly? I need to add the row ID, right? So this one would be, for example, 1, 2, 3. I should not put that like this. 1, 2, 3 would be, what was 1, 2, 3? This first guy is this guy, okay? I get this, I go back to my file, I find it, and I return it. Do we understand the difference between hash and B3? Okay. Who is smart enough and tell me what makes the hash tree, the hash index, work the best, be the fastest possible? Which part of it? For equality search, we usually use hash, but it's not necessarily that all the hash indexes work the same. You can put an index for hash. I put an index for hash on the same data set. Mine could be faster, yours could be slower. Or let's put it the other way, because you're smarter than me. Yours is faster and I'm slower. Why would that happen? Because all goes back to the hash function, yes, okay? The better the function, the faster the index, okay? Like something explodes?
No, like there's a rare like occurrence of like different.
No, no, it wouldn't. Nothing like that will happen. Yeah? Yeah. No, I don't think it would happen. I don't think any hash function would generate the same key for two different values. That would be a wrong coding. If it happened to you, it's a wrong coding. We'll come back to that. So let's stay focused here, okay? Okay, now that we understand this, right? Is there anything that I forgot? I believe not. Yes. Yeah, it would be sorted here. Yeah, I don't know exactly. Is it one by one? Or is it a list of the rows for that ID? To be honest, I don't know that. But I believe it would be a list of the row IDs because it makes it faster, no? You do know why it would make it faster, no? If I have a list of IDs as compared to one by one. Okay, now let's open PG admin. Very good. Good stuff. Now, what happens if I insert something here? Okay, let's say I created this B tree on age and a hash on first name. Okay, then I come here and insert something new. Okay, so I'm inserting this actually. What happens now? Is this insert slower than when I did not have an index, or is it faster, or it hasn't changed? Now you should know the answer. We all agree it's slower. Why? Because we have to come back to the index and update it with the new values, right? So it will be always slower. Okay, so let's say you have this country, okay, that the government is paying people a huge amount of money for doing nothing. Okay, initially that person got in and got the citizenship and he's living there doing nothing, getting a lot of money. Then people hear about it. Now we have 1 million people who came in all at once to get the citizenship, so we have to insert them all in a bulk. Okay, how do we make sure that that is not a slow process? Because we know that every single row that gets inserted, something has to happen at the back end, which slows it down. How do we avoid that? The first thing that comes to your mind is what? No, is to get rid of the index altogether, no? Right? Because it's slowing it down. Is that possible? Can we do that? Yeah, of course. Drop it, insert, create it again. Creating an index is one line of code. Yeah, you can even make it in a schedule, in a maintenance. All right, so let's do that. Let's do some inserts, okay? The good thing is I already ran this file, Lab5, so I already have my data, okay? But what you need to do, I will show you what you need to do, okay? What you need to do is first step, one, disable FK check, okay? Why? While I'm writing the second step, you tell me why that is important. Two, drop, or let's make it drop foreign key, drop index. Three is disable triggers. Who can tell me why these steps will make my insert faster? Think about it while I'm typing. Fourth one is, I'm going to ignore this for now, but keep this in mind. Disable auto commit. I will just That comes after this, not before that. Okay, so 5 is, can somebody check the note and tell me what am I missing? 5 is? I thought I have it here, but it's okay. Yeah, that we wrote. Logging, disable logging, okay? And then 5, disable login, log. Okay, how do we do this one by one? So this happens before you do the insert, okay? The create table statement I'm not running because it's a file, you just run it, okay? So here we say alter table. Let's say table name or order item. Okay, drop constraint. I don't have one here, but I think it was called something. I don't remember. Order. Let's assume that this is the name. Okay, this is the constraint, the FK constraint. So you have to do this for every table. Okay. What about index? What you could do if you do not remember your indexes, you could run this. Find a list of all the indexes that you have. I don't know if I delete them all. I deleted them all yesterday. But what you can do is very simple. If you had one, you would say alter, no, just drop index. Let's say my index was called customer INDX. That's it. Okay, you repeat this for all the indexes that you have. Disable the trigger, alter table customer, disable trigger all. Who remember this from last week? There is one task that you have to do this, yeah? So you already have the answer because your submission is not even now. It wasn't yesterday. So disable auto commit. This one I will not do it, but you could potentially come here and untick this, okay? Why would that make things faster? Anything that is making the insertion of each row take more time, we're disabling it. If I insert something into the orders table, it has to go to the product table and check if it exists, right? Here, we're assuming that the data integrity was taken care in the data pre-processing. So don't worry about it. Triggers, we don't want to do anything. Just do the insert, and then I'll run the triggers later, okay? The indexing, you know why it makes it slower. And then the auto commit. Committing means every time I do an insert, I go to the disk and write it. We know that in computer, the slowest operation is accessing a disk, whether to read or to write, no? So instead of doing it each row, and that means million times, we put everything in memory. Once we're done with that, we have everything ready, we just go to the disk once, okay? So that's the advantage of disabling auto commit. And logging, everything you do on the server is logged. You want to say, okay, for now, I don't care about the logs. Don't do anything. Just let me do the insert for now. So disable auto commit, I'm going to skip that. And for logging, it was alter table customer set. I think it's unlogged. Set unlogged. Okay. You need to do this for task 1. Once you get this done, yeah, then we do the insert. Okay? So you have to do this first, then we do the insert. Now, do I have one insert at a time? Insert into customer value this, and then 100,000 lines like that, and then the same thing for the product for this and that. A better way to do that would be use copy to insert from file. Okay, and how do we do that? I will explain this with an example, okay? Because I didn't insert all the columns. Okay, let's say I want to insert into category. I go to the column, I have cat name, and cat name English. My table name is what? Thank you. My columns are what? It should be the same order, okay? Cat name and cat name English. Where is this file that I'm going to read from? We'll go to the C drive. I put it here somewhere. Who can see it? And then that, where is the category one? Category name translation, okay? Show properties. I could copy paste, but that's okay because here I can copy both of them. So I'm gonna copy that slash and then copy the name right here. Okay? What is the delimiter? It's a comma for this data set, okay? CSV header, if your file doesn't have a header, yeah, you can ignore that. But if it does have a header, you're telling the server that ignore the first one. The same thing you do with Excel, no, nothing new. It's just that you write it as a code. So if we run this, things should get inserted without a problem, okay? So, done, okay? You have to do this for everything, okay? So I'm gonna skip that for now. I'm gonna give you a copy of this, guys. So we're gonna come here now. Now what do we want to do? Sorry? Let's learn indexing, okay? The syntax you need to remember is this. Pretty much it, nothing more. Okay? And what is this? And I'm gonna give you examples on a dummy database that doesn't exist, okay? So do not run this, but use it as a sample of a code, okay? So the default is this: create index ABCINDX on table name, let's say student, and then the column name, okay? In this case, let's make it, I don't know, age. Doesn't make sense, but okay? On a student age. What are the default settings? If I do this, which type of index got created? The default is B3. By default, it creates a B3, okay? Now, if I had a query like this, select a star from students where age greater than 18, this would have been perfect, no? If I have this, yeah, let's make it if name equal, that's somebody's name. Which index will I create? Come on, guys, make it fast. Hash, why? It's equality, no? So how do I convert this to do a hash? We just say here between the table name and the column name using hash, okay? This is the only hash index you can create. In the hash index, you cannot use any of those options anymore, okay? I believe the partition one works. It's not called partition, but that partial one will work, okay? I haven't tried it. So now let's go to another query. What is this? Concurrently. That has nothing to do with a query, actually. By default, it's not there, okay? That means during the process of index creation, yeah, I can only read data. I cannot insert, I cannot update, I cannot delete. So no write, only read, okay? But if you're in a real-time environment where it's more critical to write than to have the most updated data, it depends on scenarios, no? Then what do? You add concurrently. So you come here, let's say this guy, it's very important to make sure all the ages are correct, okay? And then here I would say index, it comes before that, no? Concurrently. Or let me just create another one in case you guys want to use it as a reference. It would be concurrently right there. Okay. What is a unique index? Let's say, let me tell you this. Primary key, anything that you define as unique when you create the table, by default are a unique index. Okay? Keep that in mind. Now, why is it important to say this value is unique as compared to not mentioning it, to make sure that the index is as fast as we want it to be? Because if it's not unique, yeah, if the system doesn't know it's unique, I have to go to the next row to see if it's matching what I'm looking for, no? In the tree, in the hash, it doesn't matter, right? I need to check if it exists somewhere else. But when it's unique, the moment I find it, I know I don't have to search anymore. Correct? All right. Let's say we have this query. Yeah. We have this query at here where email like ABC. Okay. Now, what would you suggest for indexing? If you're smart, you should know that I'm expecting you to say the same thing I just explained, no? First, you don't even think of hash. This is not equality. Like is a range, no? Okay. Now, what you need to add on top of this is email is always unique, no? We know that. So here you would say unique student email. Okay. Again, change the index names. Okay. I'm just copy pasting for you to see an example. So what is left here? We did this, that doesn't matter. This is done, this is done. Column name, that's done. What is this? Sort option and null search option. By default, this is getting sorted on ascending order. What about hash? Is it ascending or descending? Please give me the right answer. There is no order with hash. Okay? No ordering. It's just a function that creates a key. It doesn't order anything. It's randomly allocated depending on the function. It doesn't mean that from 1 to 2 comes here, from 1 to 20 comes here, from 20. It doesn't do that. The allocation to a bucket has nothing to do with ordering. But that's a good point, okay? No. Because I know where the key is in the bucket. It is slow in certain cases, yeah? When order really matters, okay? So if I have this, you need to test for a specific scenario, okay? But let's say we have this. I'm gonna, let's say a student has grade, okay? And this one is enrollment table, okay? Using grade. Oh, sorry, I just want to do the query for now, actually. So grade is equal to 100. Okay, let's see who is smart to pick this up. Grade is equal to 100, and then here we have, well, grade is greater than 90, and it's ordered by grade descending. How do you index this? We're gonna do a lot to change this now, okay? So enrollment using, first of all, it's not hash, yeah? What do I do here? By default, the order is descending. So I'm saying in my structure, it's from the smallest to the biggest, yeah? And then when I want to go back to tree, I have to read it from the largest to the smallest. Is that a wise thing to do? No, right? So it's better to make this descending, no? If I ask you for top of something, give me the top 10. It's already ascending, okay? Ascending is the default one, okay? So if I ask you for max, the top of something, yeah, all of them come under descending, okay? Or you have it specifically mentioned. Now, what is the next option? It's called null first or null last, because some columns would have null values, right? So this current semester, your grade for CSCI235 would be null. So do you want to put the null at the top or at the end? That is up to you, okay? And there is a default. So you would say null last, means I don't care about the null, I care about the marks itself, okay? But if you're searching for the null values, then it would be null first, okay? That we answered this too. Okay, we did this too. Now, before I go here, I will make a nice query where you choose, where we have more than one column. Grade is greater than, okay. Subject is equal CSCI 235. Okay. Control X and okay. Then there is another one just like this for the subject. Okay. Yeah. Or maybe even, let's make it more interesting. Okay. Looking at this tool, what do you suggest? It's either I'm always searching for the subject. Yeah, I'm assuming these are the only two rows queries you have. Or whenever I search for a subject, I'm interested in the grade as well. Okay? Okay? So one way is to do an index on the grade and do an index on the subject, no, separately. Okay. I used this example in previous batch. Let's do it here. When you were, I don't know, 13, you had to go to a party. Okay? You have few choices. One, you go to your dad, ask him. Then you go to your mom, ask him. Then you make your call, right? Or in a very functional, democratic family, when you're having a dinner and both your mom and dad are there, yeah, you ask the question. No? You connect to that? That's true, no? Okay. Even then, I bet you it's either the mom or the dad who would answer first. Who answers first? Mom? Mom? Right? Then we have those families that the mom goes as the dad goes as the mom. No, that doesn't happen in the index scenario. Okay, like the index doesn't go like, oh, go to the age. Then age goes, I'm too busy now, go to the subject. Okay, that doesn't happen here. In real life, it happens. Okay, so if I know that the mom's opinion matters the most, but at the end, I need both input. What is the ideal way to do is to ask them when both exist at the table. That is called multi-column index. And how do we do that? Very easy. You just list them. So let's say first, which one I put first now in this scenario? The one, when you say, okay, Can I go to a party and you know your mom has the first word? Would you look at your dad or at your mom? With that, your mom, no? Because if you do this to your dad, he goes like, no, that is not recorded. Okay, face impressions. Okay, we should come up with a way to do that. Okay, so first you ask the most powerful guy in this case, which is the subject. Okay, then you go get the grade. Okay, absolutely. So the way it works is it creates the index for the subject. On top of that, creates the index for the grade. Now, what happens if I search only for a grade? If I use this index, then I write this. Will it be used? This one is grade greater than 90. I'll use the same example as yesterday. Okay? Think of it like this. This is your subject. Okay? This is what? The grade. I have them here. Okay? When I want the subject only, it comes here. When I want the grade only, it goes to the table. It doesn't come to the index. Why? Because if these are the index structured, this is the data I'm looking for. It's here. This is the subject, right? The one with the coffee. It's under. Sorry, we're looking for the grade. So this is the grade. Okay? The grade is built under the subject. So if I want to access the grade only, I cannot, because I have to have a condition on a subject. I do not have a condition on a subject. I cannot access the first one. If I cannot access the first one, I can never go to the second one. Exactly. Does that make it clear now? Exactly. So if you want to access this separately, you make an index for that separately. Okay? It's scenario to scenario, but you end up making a lot. But don't worry, because the server is smart enough that if, okay, one of the exercises we do, we create 3 types of indexes on the same column. And then we tell the server, which one will you use? And it tells me I use this one because it was faster. Delete the other one, keep that one. No? Okay? So we did the multi-column. Let's now talk about the partial one. How often the people in registrar search your IDs? A lot, no? A lot, very often. On daily basis, maybe at least 1,000 times. Okay? How often, you know, I was a student here. How often do they search my ID? At all, because I'm not even a student, I'm just an alumni. And I hardly went to register after I graduated or to anywhere, right? So in my table, yeah, I have a lot of data, no? But some part of it are something I'm not interested. I never search them again, okay? Do I keep them always in the index as well? Because the way we create an index, it's always on all the data on the table. Is there a way to say, hey, I don't want everything. Just give me this part, because that's the part I always search. The rest, I don't even use them. Can we do that? How can we do that? Using the partial index. Okay, so let's say this is the query. Okay, and then here we have a status equal enrolled. Okay, these are only the students I'm always searching for. Okay, so what do? I create the same index right here, and let's say let's add another one. let's just keep it simple for now. Create this. This is a student. Okay, and then here we have, actually, let's make it more interesting. Age is greater than 100. Okay, yeah. So what we do here is we say age is greater than 100. I do not put that in my index anymore. What I would do here, I say where status equal enrolled. So what happens is it goes to the table, gets all the rows that has a status equal to enroll, and indexes only those rows. If tomorrow I come and say, find me all the people whose status is alumni, will it use the index or no? No, because alumni are not in my index. So I go to the HIP table, okay? There is something called index on expression. So if I search full name, do I have a name? Let's put it here. So we have this query, and I don't know whether the guy who's searching gonna put small letters or big letter or a mix of them, okay? So an ideal way to do a match is, for example, convert them all to lower and all to upper. So what I do is we say upper subject equal to this. Now I am not searching by the value that exists in the table. I'm converting that to something else, then using it. Can I index that new value? If I'm asking you and I have that, it means yes, right? How do we do that? You just put the expression right there. So here, okay, here, if you're typing CSCI in lower letters, is this being used? It will check, but it will it will check it, but it will not use it. Why? Because it is easier to scan the table than go to the index, convert, and then come to the table. It takes more time to do that, no? Okay? So keep that in mind. And with expression, you can put anything, yeah? You can put a very long function. That's okay, yeah? Last one is this, include. We said both indexes are, oh, we finished on time. Both indexes are secondary index. What we meant by that? What I meant by saying it's a secondary index, both hash and B3. It's 20 minutes ago.
Which is the primary key.
Exactly. That you find what you're looking for in the tree, okay? Or think of it like this. You go to the tree, you get the apple, yeah, but you don't eat it there. I don't know why, okay? You have to take it to the kitchen, clean it, and then eat it. Yeah, wash it, clean it, everything, eat it. If you are me, you just grab it and eat it, no? And then you get sick the next day. It happens a lot to me, yeah? So, how do we say the moment you get it, eat it or return it? Don't go wash, clean, and search for it again. Can we do that to start with that? Can we say don't visit the HIP table? Everything I want to get it from the index. Yes. Sometimes it's no, yeah, be careful. Okay, but since there is a syntax that I did not cover, it's a yes, okay? So let's create a query. Let's go back to one of the nice queries we had here, okay? And then here I would say F name, L name, and age is this, where there is something wrong with one of the codes, but that's okay, yeah? All right, so how do I index this? so that I would never need to go to the heap table. You guys help me. How do I index this? What do you index? Madre mia. Please watch the recording. You're all sleeping right now. And I don't blame you. It's a lot of theory. So you index the age, no? I'm going to keep it simple. Copy and paste, student, and this is age. Now I want to make sure, let's come here. I'll show you something. I want to make sure when I'm here, I have all the informations I need. Okay, let's say here I have the L name and the F name here with it, with this structure. Yeah, so this goes under this, no? So let's say here it's 20. So where is the 20 guy? So I want this to come under this. Yeah. So it's 25, this, and the row ID. So it's 20. Okay, I did the 25. I'm going to copy this because I don't know if that would gonna make issues. And then here we had row ID, which is 25 is this one somewhere. Okay, this all belongs to this guy. All this data are under this guy. Okay, so what's happening? Everything that you put in the include, it gets included in the leaf node. Yes, a little bit. We will, in the example one, you can see that it's slower actually. It doesn't improve it. Yeah. There are like special cases when this things gets used, not all the time. Okay. So what happens to get this structure, to get this guys included, what we do is we say here, include all the columns that I need. In this case, there's 2, right? Now, you guys answer this question. Will this index be used? Yes or no? As a scan only, will it be? So we have secondary index and a scan only index, okay? Index only scan. Why did I say scan only index? Index only scan and secondary index. The first one, we put all the columns we need in the index structure and then we use it. The second one, I have email and email is not included. So will it actually use the index or no? It will not be scan only index. Okay? It will get used because the index is in a student, but it will not be a scan only. Okay? Tricky question. Very tricky question. What about hash? Can I do that with hash? For those who are still with me and haven't fallen asleep. It's not about that. The bucket will never get big because hash converts it in a fixed size key. It's a fixed size key. It's 32 bits. That's it. You don't add the data to the key along with the key. Or as in, no, that's okay. That's not a problem. Hash converts one column value into a key, right? It does not take 2 columns, 1 column only. Okay, so this can never be used for hash. Yeah, it cannot take 2 columns. Okay. Let me think if I am missing on anything. I hope I am not. If I do, you can always come back here and read it. Okay. Everything I said is mentioned here. Nothing new. Now let's, there is a re-index, drop index. We're gonna jump all that and come here. Now, we learned indexing and everything, right? What we need to do is to find out if with the index or without the index, how my query is performing, okay? Or maybe I'm happy with the fact that my query is taking 1 millisecond. I don't want to index it, but I don't know that, no? I don't know the cost of a query. How do I know that? Let's run a quick query, and you will see different ways to do it, okay? I'm going to go back. This is lab 5. Actually, let's solve the question 1, or that question 1. Let's solve question 1, which is this one. And this should give me an answer because we have this data. So we run this. I'm gonna put this guy up here. All right, I need to get a little faster. Okay, so we got this guy. How do I know how did it perform? One way is to come here and click on explain. You can choose which one you want. If you want everything, just say explain, analyze. It tells you what happened, okay? Which table got access? This one only. If you have more than 2 tables, it will list them there, and then it shows you the connections. Then you go to analysis, you can see some information. Then you go to statistics, you could see some information. But this is not sufficient to do analysis, okay? To do analysis, it's better to say explain, analyze, variables, costs, timing, and let's stick to that. Variables, cost, timing. Was there anything else? Okay, then I run this. Then I see something like that. Okay? What I want you to do is copy this in here and say, no index. How did it perform? Let's have a look. Why it became like that? I think I know why is it doing it like this. When I'm running that one first, this one, it's giving me something. Oh, okay, now it's correct. It is correct. All right. So here, let's see. Let's have a look at this and learn how to read it. There is cost 0, and then there is another number 3241. Okay? What is the first one? What is the second one? The first one is how fast I access the table. Okay? Like when I started at the very first second, at the 0 second, I started reading the table. Okay? The second one means how long it took to scan the table. Okay? All right. Then we have rows. Row here. Rows 11585. Where's the second row? Yeah, and then here 11635. What's the difference between the first row and the second row? They are different numbers, so definitely it means different thing, okay? So let's say my sister calls and says, Asma, we need you at home. We miss you so much. Yeah, we want to see you. Then I go like, oh, guys, just tolerate it, period a bit. I'll be there in half an hour, okay? Then I hit the road. There is a traffic, and I get there in 1 hour, okay? I'm hoping by then nobody killed themselves because they missed me, but okay, it took longer to get there, yeah? So what is the first half an hour? Something I estimated. I estimated that based on my driving, it should, and the fact that in my head that there is no traffic, it takes me half an hour. But then the reality kicked in. There was a traffic, yeah? My car broke, something happened, no? And I reached after somebody killed me on the way, and I never reached. And I have like 100 enemies already, no? Okay? So the second one is the actual time. So the first one is the estimate. The first one is estimate. The second one is actual. How does Oracle estimate? I estimated based on the statistic, for example, that, okay, the road from here to there is 5 kilometers, or I don't know, 45 kilometers. I am driving with this speed, it should take me that many hours. right? The same thing that Oracle, PostgreSQL does, right? It says, these are the number of the columns I have, these are the number of the unique values I have, these are the so there is a statistics about the data in the table that helps the server make an estimation. But then when it is started, it gets the actual one, no? Okay, that's done. Now let's go to planning. Okay, let's go to planning. What is planning? What is execution? I tell you, go to a lane. Yeah, it's the first time you want to go to a lane. Do you just hit the car and go to the car and hit the road? Usually people plan, no? They say, okay, let's check the map. These are the roads. Let's get this and this. Let's get some burgers, some bread, some barbecue stuff, right? That's the planning. But that doesn't make it happen, no? You just planned it. You actually have to do it. The planning usually takes a shorter time than the execution, no? So that's the same thing, okay? So, or the server looks and says, okay, I have an index, I have this, I have that, I will try using that one, then using this one. That is the planning, okay? Once it's done with the planning, it says, okay, now let's get it done. That's the execution time, okay? Now let's do one index and then compare them. Actually, what I will do is, I think I have the file from yesterday. If I go to my, yes, I'm gonna open this to make our life easy. First, looking at this, how many indexing can you suggest? It's an equality check. So the first thing that should come to your mind is hash, okay? Would you check the B tree as well, just to see if it's used or not? Or is it gonna perform better than hash or not? Yes. What is the third one that most of the students miss? Sorry? You have some columns which are not in your index, which you could put in your index using include, right? So you use include to make sure everything is on that table. Now, there is a trick with that, before I forget. Let's come here, and before I show you, can somebody grab a piece of paper and start writing your ID numbers on it? Before we come here, let's go to the first one, right here, okay? Let's say I am here, okay? I want everyone's attention here. I am here, okay? And I have some search. Now this guy, GSD whatever guy, where are you? Here. I decide to change my name. Here, yeah? It was very difficult for people to pronounce that. Can you pronounce it? Okay? So I felt like, okay, if I want to get anywhere in my life, I have to first change my name. Otherwise, I fail my courses, I don't get a job, and I'll be homeless. Okay? So I change my name. Right now, I change my name, and somebody is right now searching for people who are older than 26 to win a lottery. How unlucky I could be, no? Right? I am that unlucky, yeah? In certain areas of life. Okay. So, what should the server do for that? To force me to go back to the table and read it instead of reading it from the index. Because somebody is losing a 1 million lottery already. That's not something you want to happen, no? There is something called the visibility flag on the table, okay? So let's say here is visibility. If this is turned off, which happens because something just got executed or updated or deleted or inserted or whatever, then I cannot do the scan only. I have to go back to the table because the table is telling me I made some changes. Don't read your data. You cannot read your data. You have to come back to me. Yes, the index is used, but it has to go back to the heap table to read. Okay, so that was important. Now let's quickly have a look. here, which one was it? Okay. I will post this online after the session. Let's, where is the font? Okay. I really don't want to be bothered with that. This is the list I want to do, is to be bothered with formatting right now. And then let's make this like that. And let's keep that like this, okay? So the idea is this. You come up with the different scenarios of indexing. Can you have more than one index? Yes, they have 100 indexes, okay? So I say, first I will run it without index, and I will see how it performs. I will not analyze it yet. Then I do it with B tree. I copy it here. I drop the B tree. Then I copy the hash. I see the performance. I drop the hash. Then I see if it's better if I use include or not. Then I drop it. Then I will analyze and see which one will be used by the server, okay? And I will reason about it. If you have all three of them in the planning phase, it decides which one to use. If you have only one of them, then you're not giving him a choice, no? All right, let's compare something very quickly. First of all the three indexes are used. Sometimes you have the indexes even ignored completely, okay? So in our case, none of the indexes got ignored. They are used. That means they were a good idea, okay? Now, let's check here. The heap table cost here is 0. With this is 4. What happened? Because before I go to the heap, where I have to go? To the index, okay? So if I have to come here first, you see the cost is now 0 on the index. I went to the index first. Once I'm done scanning, getting the row IDs, I went to the heap table, okay? The same thing for hash, no? The same thing for include. Now, which one is faster in index scan and the hash scan? Hash. So in both, finding the row IDs, it's faster. In terms of going back, because this was faster, this will be faster, no? But why is it slower? Look there, you tell me. The execution is taking long because of the hash algorithm. You're very awake today. Very good. Keep it up, okay? So, or I am a very good teacher. Let me get some credit for that, okay? So it is because of the hash algorithm, okay? Now here I put some analysis. For example, why my hash is not used. Okay, the best way to know as a person which one is better is to add this to that, no? Add the planning with execution and see how long it's taking. If you do that quickly and mentally, you can see that this one is fastest one if you add them together, right? So if you are a server, which one you use? Of course, the fastest one. You don't say, oh, everyone is using hash for equality, so I have to use hash for equality. No. You just see which one fits this particular scenario better, okay? One of the cases that, one of the reasons that this is not used, the hash, is the algorithm. The other one is the fact that hash works when you have better for a string, when you have long strings, not like MG, yeah? Try that out, okay? So this is what I want you guys to do, is to come up with different scenarios, yeah? You can say, okay, I'm gonna use a composite index. Yeah, I'm gonna put 3 columns together, but then the order matters, no? Right? If you're searching by first name and last name together in a single query, would your index be leaded by the first name or last name? Last name or first name? First name? Last name? Why? 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 Remember, we said the second index is built on top of the first index. So less traversing on the first index would be better. Which one has less unique values? First name or last name? Last name would be more common, no? Right? If you're in a country where first name is common, I think there is in Indonesia, everyone, all the girls are called the same thing, all the boys are called the same thing. Yeah? So in that country, just do the first name, okay? So it depends on where you are as well, no? Okay, any questions? Is it clear what I want you to do for the task?